In this video, I'm going to talk about the different types of intermolecular forces. I talked about intermolecular forces in a previous video, but just to refresh your mind, they're attractive forces between independent particles that allow them to stick together, but they're not bonds. Bonds are what we call intramolecular forces. So in this video, I'm going to talk about the first three types of intermolecular forces, and I'll talk about the induced intermolecular forces in the following video, just to not make it too long. The first type of intermolecular force is what we call an ion-dipole interaction. So, as its name says, it's an attractive force between an ion and the pole of a molecule of opposite charge. So, just to remind you, there are two types of ions: anions, which bear a negative charge, and cations, which bear a positive charge. Just so you can visualize it better, I'm going to give you an example of how an ion-dipole intermolecular force works. So the most common example is just NaCl. NaCl. And when it interacts with water, right here, it will separate into its ionic form. So we will have Na plus and Cl minus, and that is now in an aqueous state. But what is really happening is that there is an ion-dipole force between the water molecules and the different ions. So let's start with sodium. Sodium is a cation, it bears a positive charge. So when it interacts with water, let's draw a molecule of water. We have an H here, we have an O here, another H here, and it's single bonded to each of them. Let me fix that bond. And we have two here. But as you may remember when I talked about polarity, water is a dipole, so it will have a side that is negative and a side that is positive in charge. So the oxygen, which is the most electronegative atom in this case, in this molecule, will have the negative charge, and the hydrogens will have the positive charge. So what happens in an ion-dipole intermolecular force is that there is an attraction between the ion and, as the name says, the pole of the molecule of the opposite charge. So in this case it's this side. So there will be an attractive force between these two. Now remember, this is not a bond form, it's just an attraction between two different molecules. And I should don't attract it to the pole, just attract it to the element. So oxygen is the element with the electronegative charge. So what happens next is chlorine. Chlorine is an anion, so it has a negative charge. Chlorine will just be attracted to the positive end, so it will be attracted to the hydrogens. So we have two ion-dipole interactions between this. The sodium, which is positive, will be attracted to the negative side, or the oxygen, and the chlorine, which is negative, will be attracted to the positive side. And that's just an ion-dipole interaction. Now the second type of intermolecular force we're going to talk about is called hydrogen bonding. And don't let the name confuse you. As I told you before, intermolecular forces are not bonds. A hydrogen bond is an attraction between a hydrogen and one of these three elements. So fluorine, oxygen, or nitrogen. So a hydrogen bond will only occur with those three elements. You cannot have a hydrogen bond with something like carbon or something like that. Just fluorine, oxygen, and nitrogen. And well, just to picture it, the easiest way is just thinking of water again. So we have water here, and a different molecule of water here. And let's say we have another molecule of water here. Just So a hydrogen bond will occur between an oxygen and a hydrogen of different molecules. So this is not a hydrogen bond. It has to be of different molecules. So there will be a hydrogen bond between this oxygen and this hydrogen, or this oxygen and this hydrogen, or this one with this one, and so on. So it's just basically an attraction between a hydrogen and one of the three elements I mentioned before. The third type of intermolecular force I'm going to talk about is called the dipole-dipole intermolecular force. So unlike the ion-dipole one, in this case we have two different poles instead of an ion. So in other words, what this means is that something like this will happen. So a side is going to be delta positive and a side is going to be delta negative, and there will be an interaction between those. So let's do an example. So let's say we have this molecule, two hydrogens and a sulfur, and it interacts with the same molecule. Now sulfur is not one of the elements that the hydrogen can form a hydrogen bond with, so this cannot be called a hydrogen bond. And like what we saw in water before, this molecule will have two different poles. The hydrogens are more deficient in electrons, so they have a more positive charge with delta plus, and the sulfur is more electron negative, so it's going to be more electron rich. This will be a delta negative. And the same will happen here. This will be a delta positive, and this will be a delta negative. So as you can see, there will just be an interaction between these two. I'm going to move this up a little bit. Delta positive. So there will be an intermolecular force between these two, or just the hydrogen. Not just the hydrogen, just like the positive side of the molecule, the positive pole of the molecule. So it's just a dipole is just two different poles interacting. One will be delta positive, one will be delta negative, and that's just the force between them. And so just to summarize, ion-dipole, we have an ion on one side, like sodium, and a dipole on the other side, like water, and there will be an interaction between them. I should draw this the other way. Oxygen, hydrogen. This part is delta negative, so these two are attracted to each other. Hydrogen bond, we have two waters. The hydrogen will bond to fluorine, oxygen, or nitrogen. So there will be an interaction here. And dipole-dipole, we have two different molecules that are both polar and have different poles. So this will be delta positive, this will be delta negative. And the same molecule, H, this will be delta positive. There will be an interaction between the poles of opposite charges. Well, I'll talk about the induced intermolecular forces in the following video. If you found the video helpful, like it and share it with your friends.